Okay, in this video, I'm going to be talking about an H-bridge, which is the essential of an inverter. So first of all, let's look at what we mean by an inverter with respect to pulse width modulation. So if we have a DC voltage and we want that to go into our inverter, then we want it to come out with a signal that looks sinusoidal like that. So how do we go about doing that? Well, we want to basically do everything in terms of a switch turning on and off. So there's three different ways, or two main ways, that this is done. There's the inexpensive way. So here is our sine wave, and what they do, and this is called a modified sine, and so what it does is it goes up like this. And so it has a part that's up, has a part that's flat, and has a part that's down. So that's what it looks like. Okay, so the other thing that we want is they also do what is called a perfect sine, and so let's look at that in terms of a pulse width modulation. So let's copy this in. So if we look at this in a little bit of detail, this is what the sine looks like. So let's analyze what this is showing. Okay, so what we do is we have this triangle wave, and whenever we're above the triangle wave, we make it a high, and when we're ever below the triangle wave, then we make it a low. So for example, this part of the sine right here is high, and so you see that if I go down this pulse width signal, that it's almost always on with a little bit off. If you go down to this signal right here, which is close to 0, you see that it's off a lot more than it's on. And then over here, it's closer to 0, and so it's off less. Down here, it's basically the same thing, except for it's flipped down and negative. And so then this is the top part of the sine, small value, large value, small value. And so then this is the PWM signal for the for our inverter. So I can either do this type of signal, or I can do this simpler thing here. But what we need in this block right here is to be able to either give a 0 value, a high value, or a low value. Okay, and then we're going to do that with our H-bridge. Okay, so let's look at this again. So we have our voltage, and then we have some resistor over here. And we're just going to draw it this way. So in one case, we want to be able to go like this. Okay. In another case, we want to go like this. And then in the third case, we want it to be a 0. So in that case, we want it to look something like this. Okay, so you can kind of see in this case, my current is going this direction. In this case, my current's going that direction. And then over in this case, it's just a 0. Okay, so this is what we're trying to create. And so we're going to do that by creating a set of switches. And so we're going to have one switch here and one switch here with my resistor connected in between. Okay, so when I have this, you can kind of see that I can say, oh, I want this switch to be closed, and I want this switch to be closed so that it flows around like that. Okay, or we can say, oh, I want this switch to be closed and this switch to be closed, and then I flow around like that. So I basically have these 4 switches, and I can create the configuration for them. Okay, and what do I not want? Okay, I don't want, so let's call this S1. S2, S3, and S4. Okay, so let's come in here and look at these possible combinations. So I have S1, S2, S3, and S4. And we're trying to look for all of the possible combinations. So really, we just have to create a digital signal with all the possible combinations. So this would be switch 1. They're all closed, closed, closed. Sorry, open, 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 closed, open, open, closed, open, and so on and so forth. And then we're going to type out all of these different numbers. Let me skip ahead and just pause it and do this without you watching. Okay, so here are all of our switch combinations, and now we got to figure out which ones are bad. Okay, so what we want is we want to make sure that there's here are all the things that we don't want to happen. We don't want a short from across the source. Okay, and we don't want the load to have a open lead. Okay, so let's start with this first one right here. So this first one right here, S1 is open, S2 is open, and S4 is closed. So that would be like this. So if I were to redraw that circuit, it would look like this. So it would be, we would have a resistor, and so it would look something like that. So it's basically open right here, open right here, open right there. That one is number 2, an open lead. Okay, so that one has an open lead, so we don't want that. We don't want this one because that's an open lead. This one's going to be an open lead. Okay, so now let's look at this one. So in this case here, we'll erase this. Okay, so in this case right here, S1 is open, S2 is open, and S3 and 4 are both closed. So that looks like this. So if I redraw that circuit, it's going to look like this. And so in this case, we are doing both 1 and 2. So of course, in 1, if 3 and 4 are both shorted, I'm shorting out my source, and so then I would get really high current and burn everything out because I don't want to short out my source. So we want to make sure that 3 and 4 are never on at the same time. And we want to make sure, and so where's my 3 and 4? So here's 3 and 4 both on, 3 and 4 both on, 3 and 4 both on. We also have to make sure that the 1 and 2 are never on because that's going to be the same thing. So if 1 and 2 are both on at the same time, then we don't want to allow that, and we don't want to allow those. Okay? So this is how I've eliminated all of those. Okay, so in this one right here, I have S2 is open and 4. 2 and 4, that looks good. So now let's look at these different states. So this state here is going to be my 1. So my 1 is open and my 2 is closed. So I'm going to have this. Okay, and then my 3 is open and my 4 is closed. So it looks like this. Okay, well that's fine because there's no current shorting the source out and my load is connected to 0. Okay, so then we have 2 and 3. Okay, so in this case, 2 is open. 2 is closed, and 4 is, and 3 is closed. Okay, so in that case, so this is my 0, this is my current going this direction, okay, which would be my minus V, okay, because it's going the opposite direction. So now let's look at, whoops, this one has a dangling one. Okay, so we can't have that one. Let's look at this one. So this one is it has 1 connected and it has 4 connected. So in this case, you see my current's going this direction, and so then this is going to be my plus V. Okay, and then I have my last configuration right here, which is 1 is on and 3 is on. So it's going to look like this, and then this is also my 0. So you can kind of see that now I have 4 possible configurations, and so if I control which switches are on and off, I can control which states I'm in. Let's redraw our switches. Okay, so then the last thing we want to do is, well, how do I make switches? Well, my switches are all just going to be MOSFETs. So I'm going to connect up each of these switches. And so what we see here is that because it looks like this is called an H-bridge. So with an H-bridge, I can create 0, so I shorted my load. I can create minus voltage, plus voltages, and zeros with all of this. So now if I come back up and look at this, so then I'm going to have, so I'm going to have these 2 configurations. So I'm going to have an up, a 0, up, 0. Down here I have a down, I have a negative, and 0, negative, and 0. So I can create this structure using this H-bridge configuration, where I'm going to replace these switches with transistors, and then I'm going to control all 4 of these with my microcontroller. Okay, and then I'm going to be switching one at a time to get everything to work out. And this is how an H-bridge works. So this is my H-bridge right here.